Like what are the discussed about the last session is AAA based authentication method. In AAA, what was the first A? Authentication is a method of identifying a users, and next A is what? Authorization. Authorization is a method of what a user can do, like level permission. So one more A is a accounting. Like user is being done, what other information is being done by user is going to be gathered. So generally in the real time, like all the network engineers will log into networking devices. There may be routers login or switch login or you have like a firewall login or wireless login, whatever the logins. The login authentication will go to AAA server and AAA server will give the will do the three actions. So AAA based on that authentication information, you can get the logs and privilege levels. So the short form you can say is centralized database information to mine. Okay, and password recovery also we have discussed. Like you forget password, you don't know password to log in with our Cisco routers. Like how you can revert it? So generally, each and every Cisco router has the default configuration register value is 0x2102. So this register value, this configuration register value will have the boot sequence of host, room, flash, NVRAM, and RAM. So this is a boot sequence, right? Like your passwords and protocols, IP address, all the configuration permanently will store in NVRAM. In boot sequence, when NVRAM will come in the picture, device will ask the password. But if you don't know password, then what will you do means you need to skip NVRAM in the boot sequence. So to skip NVRAM in the boot sequence, what we'll do, we'll change the register value as a 0x2142. So 0x2108 it is a default configuration register value for proper boot sequence. 0x2142 is a register value to skip NVRAM in boot sequence. If we skip NVRAM in the boot sequence, now without passwords, we can enter into router modes, like user mode and privilege mode. After entering the modes, now we can recover a password either, we can configure new passwords. So once your password has been recovered and will default, will configure the back to default register value. And if you restart the router, then you can get access. But one more important point is once if we change the register value, your all router interfaces, LAN interface, WAN interfaces will go to shutdown state. Again, we need to give the command is what? No shutdown for each interface to active the interfaces. So don't forget that. Like once you have changed the register value and password has been recovered, then if you switch on your router, your interface will be not active. So after changing register value, automatically your interfaces will go to down state, shutdown state. So we have to apply like configuration is there. Everything configuration is there, but only thing is what your ports will be go to shutdown and we manually need to activate it. No shutdown command. All right. These are the topics are being covered the last session. So today let me continue with how to take the iOS backup files. Configuration backup, iOS backup files. So today our topic is iOS and configuration backup files. Environment configuration, permanent configuration backup files. Like how to take the iOS and configuration backup files. So first you tell me guys, what is the backup? Why backup is required? So backup is nothing but a copy of original. A copy of original file. So this is my device. There can be router or switch, whatever. So this is my device. So when I have purchased a router, by default you can get IOS, right? Original file. You can get the file, right? Now what we'll do, we'll configure IP address, we'll configure passwords, and we'll configure routing protocols, we'll implement all the protocols. See, all the configuration permanently will be stored in a which memory and VRAM. So which type of files? Startup configuration files. Like where exactly will IOS file will be present? We have a one special memory called what? Flash. So IOS file is okay, original file and configuration file is A, but suddenly my router is being rebooted, restarted. And maybe my IOS file is being corrupted. Maybe like for power fluctuation, sometimes your NVRAM is being getting damaged, corrupted. NVRAM is being corrupted. So you can lose your configuration files, right? What we'll do in the real time is every day we used to take backup in your even we have some options which is automatic backup files are being recovered, but still so how to take the manually backup configuration backup files. Let me explain it. So LAN is possible. So your router should be connected to LAN end user device. So this device should be a server. It can be TFTP server or FTP server. Like how we can make your PC server. Let me install some application called TFTP. So once if I install the TFTP, now my PC is acting like what? TFTP server. For example, router IP address is 10.0.0.1. Your TFTP IP address also should be in the same network. IP address is 10.0.0.100. 10.0.0.1 is a router IP address. 10.0.0.100 is a TFTP server IP address, right? Now we can take backup files via TFTP server. So what type of files you can take the backup? You can take your iOS backup file and you can take your startup configuration file. So initially, you tell me, guys, what is the use of backup files? So we are just taking a safe side. We are just taking a one copy of original. We are not taking the original files, right? Original file still is there, but just you are taking what one backup file. If something is went wrong, something is down, your iOS file is corrupted. Now we have the file, we can restore it, right? For example. Okay. So very simple and very simple configuration. Take the backup file from router privilege mode, not even the configuration mode. So router privilege mode, copy source destination. Copy space source destination. Is not actual commands, just I'm telling example only. Copy source and destination. But now we need to identify which one is a source and which one is a destination. Like the file which we are taking the backup, that is a source. The file where is going to store, that is the destination, right? I repeat once again. The file which one is taking the backup, that is a source file. A file where is going to store, that is a location, that is what? Destination. So I want to take the backup is a flash. iOS backup means flash is a source. So where iOS file will be stored? In TFTP server. TFTP is a destination, right? So copy flash space TFTP is the command. Copy source is a startup configuration. Destination TFTP. That's, let me show you the practical. This router is a 10001, right? Host name is head office. So let me install one server here. Take the backup file. Take a server. See, whatever we are doing the practicals, these practicals only to understand, only for simulations, only for practice, only labs, right? But the same thing we are going to implementing in the real devices. So whatever we are discussing, what are the practical, the same thing as in real time also, but we are going to implement it in what? Some real devices. In the real means if you go for IT companies, they have the real devices. So you can have the more options also in the real devices. But in the Cisco packet tracer software, we have a few options, but still 99-100% also can do it. But still, if you go to the real time devices, you can get have the more different live applications. But you main focus on the concept. The terminology is required. Concept is required. Let me assign IP address to server 10.0.0.100. Go to services, maximize it. TFTP, where is TFTP? Right, TFTP. So already we have some backup files, is it? Let me remove the files. I removed all the files here. I'm going to execute some commands to take the backup. In router privilege mode, so your server is connected to switch, right? The switch port is still in the orange color, the amber color. Port is not activated till now. The running configuration was the problem. Privilege mode, can you use copy? Startup hyphen config is a source file. Destination is a TFTP. Enter. You're asking one question, right? What is the question? Address, name of the remote host. Name of remote host. Means address means IP address. Here TFTP server IP address is asking the question. What is the server IP address? 10.0.0.100. Destination file name. You can execute any file name. You can give any file name. Example NVRAM. So now this file is going to save as NVRAM is a file name. So by saying the NVRAM file name, can you tell like, hey, this is a file for so and so router? No, it's just showing is what NVRAM is only file name. But we cannot say exactly by seeing the file name, this belongs to so and so router, right? If you don't define any name here, the default by default is going to save as a hash office config, head office config. So what is the host name? We have the router, that is the default name. So we especially we don't need to enter the any names. Let it be the continue, enter. Writing startup configuration. I think still the server and switch connectivity is not properly connected. Is running on backend. showing here timeout. Error opening TFTP. Not has been activated, right? Let's try it once again. Copy startup config TFTP, server IP 10100, destination file name, enter. Copy it. Now where you can find the file on server, TFTP service. This is the file, head office config file. Same like a flash also. Show flash. Now this is a flash information. Show flash command, flash information, iOS information. So you try to find out what is the file name of flash, iOS file name. So generally, text files we can identify by seeing the extension called .txt, .jpg, .mp3. By seeing the extension, we can find, right? So iOS file name is what? Yes, Pradeep. .bin. .bin files are what? iOS file. You can see here .bin, but starting is a C. Cisco 2900 universal, right? Just copy this entire, as they say, copy. Now you can use command, copy source, which is flash, destination, TFTP, source file name. What are the copied? That file name, paste it here, enter. Server IP address 10.00.100, destination file name. Let me continue, enter. Copy. The backup file is being. Yeah, here I can get the backup. So I have a two files are present in my computer, my server. Backup is been done. So why use the backup files? For the use of backup, your original files are being removed, damaged, corrupted. We can restore, right? Now let me show you how to restore it. Same command. Copy TFTP startup on 10.00.100. Source file name. Startup config is source file. Destination file name, same thing. Reverse the command. Starting copy startup config. So restoring of flash, we have the different type of methods. One of the method is this one. And if you are getting error means, you have to execute one command. You have to make TFTP. You have to make your router as a TFTP server first. Then you can use TFTP is not supporting here. Your real routers, you can execute TFTP server, then you can restore it. Same command. Copy TFTP flash. Copy TFTP startup config. So these are about iOS and configuration backup file. For everyday schedules, we require some applications, third-party applications, and that applications if we configured, then you can automatically can get. We have applications is here in the PRT, IBM Tivoli, ASAP Code, SolarWinds. So many monitoring tools and so by doing that applications, you can schedule it for everything. So when we had discussed about routing, you remember routing part? RIP. OS, we had discussed, right? So let me back one topic. We'll discuss about the both points. RIP will utilize the more bandwidth by sending periodical updates for every 30 seconds. But OSPF will do what? OSPF has the incremental updates. When there is a change, then only updates. But still, OSPF uses hello packets for to maintain the neighbor. So these hello packets for how many seconds? Hello packets for how many seconds? OSPF hello packets. Remember, guys? OSPF hello packet for every now, yeah, 10 seconds. Right? HSRP hello packets are 3 seconds. Okay. Okay. This try to understand this topology here. This is my head office. Branch 1, branch 2, and branch 3. The head office and branch office 1, they are connected via serial 0/0, and this interface network is 172.16.0.0 network. And head office and branch office 2 also connected with a serial 0/1. Serial 0/1, and this network is 172.17.0.0 network. And head office and branch office 3 are connected via serial 0/2. Network is 172.18.0.0. And head office LAN interface. Head office LAN. Switch. And switch to end user device. So head office fast Ethernet 0/0. Fast Ethernet 0/0 IP address is 10.0.1. Okay, guys. Now you tell me for head office router, total how many number of network interfaces are available? For head office, total number of interfaces. 4 interfaces, right? Okay. Now I have decided to configure OSPF in head office router. What was the configuration? Router OSPF process ID 123 something. Network ID, wildcard mask, and area ID, right? How many commands you need to enter here? Network space 172, wildcard mask, and area 0. Is the first network. Now head office OSPF router configuration has been finished. No. So we have to advertise all networks, right? Like how many networks are to advertise? Network 2, 3, or 4. Network space 172.17.00, wildcard mask area 0. Network space 172.18.00, area 0. Now OSPF configuration is finished is done for head office. No. We have to configure what 10 dot network also, right? Yeah, let me advertise a LAN network which is 10.0.0.0 wildcard mask area 0. Now OSPF configuration is being finished on head office. Now what head office router will do? Now head office router will start sending hello packets for every 10 seconds. See the hello packet mechanism, how is happening is, so first command network space 172.16.00 wildcard mask area 0. So first command, if you entered this, now head office router will start sending hello packets via serial 0/0 interface for every 10 seconds. Right? Similarly, network 172.17.00. If you advertise the second command, now what head office router will do? Will start sending hello packets via wish interface serial 0/1 for every 10 seconds. And network 3 172.18.00. Now hello packet will start sending via serial 0/2 for every 10 seconds. Now once we configure network 10 dot network, now every 10 seconds hello packets will go to via which interface, guys? Fast Ethernet 0/0 your LAN. So means for every 10 seconds, which device receiving hello packets here? Yes, which is receiving hello packet for every 10 seconds. If we configure 172.17 like via serial 0/0, if we send the hello packet, other neighbor is a B1 router. Branch office 1 is the neighbor. Now branch office 1 will give the reply and head office branch office will become the neighbors and they can communicate. The same like if we send hello packet via serial 0/1, branch office to router is connected, it will give the reply, head office and branch office will become the neighbors, then they can communicate. Even head office to branch office they also can send hello packets and they can communicate, right? But thing is what here, by sending hello packets to fast Ethernet to the switch for every 10 seconds, what's the use of it? So what switch will do? Receiving hello packets which cannot understand the OSP of hello packets is dropping your traffic. You're dropping your hello packet. So what is the problem? What is the drawback here? For every 10 seconds which is receiving hello packets and dropping the packets, your network bandwidth is being utilized, wastage. Like unwantedly hello packets receiving for switch. So we have to send hello packet to branch 1, branch 2, branch 3, right? Then why hello packet to switch? Not required, no need. But what router will do every 10 seconds sending hello packet to switch also? Unwantedly switch is receiving the hello packet and doing the broadcast in the LAN. If switch is a 48 ports, what switch will do? So this YSPF hello packet sending to 48 ports. Now 48 ports are going to disturb, right? So how to stop the hello packets? So if we stop the hello packets, now your LAN network performance is good. We can minimize, we can reduce the wastage of bandwidth also. So implementing of protocol is very simple. We have discussed about OSPF and you can configure, but it's not, it makes sense, right? Like what is the major challenges of implementing of OSPF? So how OSPF is good doing the function, how to control the traffic, these are all the parameters we need to go main focus on it, right? So implementing of OSPF protocol means everyone can implement it. Thing is after implementing, what the OSPF is doing is unwantedly sending hello packet to a switch. You need to stop it. Like OSPF has to maintain entire view of the topology with respect to each router. Routing table size too big, then create areas. Like in OSPF in LAN, one router, all routers going to start updating. Number of multiple times updating, broadcasts happen. Then how to avoid that? So then to avoid that, what we'll do? We are going to DR and BDR election process. Do you remember that? DR and BDR election process? I discussed designated and non-designated backup designated routers. DR BDR elections, right? So these are all the parameters. Implementing of OSPF is very simple. After that, this is the main issues, main challenges. Today our challenge is how to stop hello packets. So how to stop hello packets means, so first you try to understand how hello packets are being started. Why hello packets are sending? When hello packets are started, like once if we configure network space 172.16.0.0 network, we configure it now hello packet is started, right? Via serial 0/0. But our concept is how to stop hello packets. Then what will you do now? You tell me, guys. So by advertising 10.0.0 command, then hello packets are started via fast Ethernet, right? Then how to stop it? Don't configure 10.0.0 network. Okay? Is it right? Hello, can you give me, can you hear me, guys? Are you following? So the problem is here, if you don't configure 10 dot network, no hello packs to fast Ethernet. Okay. A condition has been satisfied. No problem. The same time, what happened? How branch office 1 will come to know what is your LAN network ID? How branch office 2 will come to know what is your LAN network ID? How branch office 3 will come to know? So if you don't configure your LAN network information, so there is no complete communication between the branches. It's very danger before then. The thing is what? We must advertise the 10 dot network also. If we configure 10 dot network, hello packs is started. Our requirement is we have to configure, we have to advertise all interfaces. At the same time, we need to stop the hello packets on fast Ethernet. So to stop that, we have to configure one mechanism called passive interface. So what I'm doing is, let me configure here interface fast Ethernet 0/0. So this interface, we're going to configure what? Passive interface. Passive interface. Once you configure passive interface of fast Ethernet 0/0, even if you configure 10 dot network, no hello packets on fast Ethernet. So to stop hello packets, we configure what? Passive interface. The thing is, passive interface is recommended to configure on which interfaces? Fast Ethernet interfaces, LAN interfaces. If we configure passive interface on your WAN interfaces, serial interfaces, then what happened, guys? If we configure passive interface on serial 0/0 passive interface, now no hello packets on serial. Means no neighbor and branch one and branch head office. Then no communication also. That's a very important point. So Passive interface is recommended to configure on your fast Ethernet. If you configure passive interface on WAN ports, where serial ports, then what happen? No hellos on WAN, no database exchange, no communication. In Cisco exams, in Cisco certifications, they can give one question actually. Scenario is this one. We have configured OSPF in have configured all advertised networks are advertised and connectivity, configuration, everything is okay. But still my head office and branch office, one is not communicating. What was the problem? Everything is okay. Configuration, OSPF is configured to both sides. R1 and head office is configured. Connectivity okay, protocol is okay, everything is okay. But still is not communicating means what happening guys here? Maybe on serial 0/0, passive interface is enabled. Yeah, even sometimes we use a passive interface enabled on WAN ports also. The scenario is what? So temporarily, like temporary, we want to stop a communication via head office to branch office. For temporary, we want to stop the communication for head office to branch office. Then what will you do? You remove the cable. So removing of the links are very dangerous, right? So generally, we don't touch the physical. Let me continue the physical setup. Then what we need to second option? Remove configuration of OSPF. If we remove the configuration of OSPF, communication not only between head office and branch one, so remaining office also no communication, right? So my requirement is a temporarily only have to stop the communication from towards head office and branch one. Then what I will do is I just enable passive interface on the serial. Now no hellos and no neighbor, no database exchange, no communication. So whenever you want to enable communication again, we just remove the passive interface and hello packs are started and branch one head office will start doing communication. Okay. So this is the point actually. Passive. Passive interface is configured to stop updates, exit out of the interface. If passive interface is configured between the routers, what happened? Between the routers, if we configure, no updates will be exchanged. Try to check when you are going to configure passive interface. The same concept for RIP, OSP of even RIP updates to stop on fast Ethernet in EHRP for all protocols same. This is for RIP. Router RIP, fast Ethernet, passive interface, fast Ethernet. Let me show you the practical for EAGRP. Hello package. Router EAGRP is number 100. Network 10.0.0.0 172.16.0.0 172.17.0. Now privilege mode, debug, EAGRP package. Now you can able to see right the screen, right? Hello packs have been sending. If you check here, sending hello on serial 0/0/1. I'm sending hello on gigabit Ethernet. Sending hello on 000. Again 0/1. Again gigabit. For all interfaces, for every 5 seconds, EHRP is to send hello packet. If it's OSPF, 10 seconds. If it's RIP, 30 seconds. So by sending hello packet on via fast Ethernet serial 0/0, your R1 router will be the neighbor. Sending hello packet to 00, your R2 will be the neighbor. Then why we require hello packet and gigabit Ethernet not required, right? So how to stop it? Let me configure passive interface. Router EIGRP is number 100. Passive interface gigabit Ethernet 0/0. Okay. Back to privilege mode. If we check once again the debug package, now we can able to see hellos on only on serial. See hellos on only on serial interface. No hellos for gigabit Ethernet. To stop the mounting, you can use space alt command and debug all. So let me remove the static routing and let me explain one more. In generally, to remove the static routing on any routing protocol in our physical router, we just use one single command is no IP routing. If someone is using any Cisco packet traces software on point to some latest version, use no IP routing command. Alright. In R1 router, branch office 1 router, show IP interface free. How many interfaces are available, guys, here? How many interfaces are being activated? 2 interfaces. Let's consider this my R1 router. My R2. R3. Number of routers. R1 to R2. If R1 also connected to some routers, branch 1, branch something. So based on our we have seen here 1, 2 interface, right? If R1 has a 3 interface or 4 interfaces, network 1 17 dot 1 dot 1 dot 1 slash 24. And next IP address is a 17 dot 1 dot 2 dot 1 slash 24. 17 dot 1 dot 3 dot 1 slash 24. So these all IP address are belongs to same network or different network? Yes, please. If all the 3 networks are same or different network? See 17 dot 1 dot 1 dot 1 2 dot 1 3 dot 1 slash 24, right? So slash 24 means is a customized. So customized to slash 24 means what, guys? We already discussed slash notation. So slash 24 means what? 24 network bits. So 24 network bits means 8, 8, 8, 8. So first 3 8s are network portion. Okay. So here first octet is a network. Second octet is also network. Third octet network. Fourth octet is host. So first 3 octets are network portion. First 2 octets are same, but what is the last octet? Third octet is what? 1, 2, 3. So now tell me, guys. So these are the same network or different network? Come on, Mustafa. Still you are getting confused. Third octet is a 1, 2, 3, right? It's a different network, customized. Okay. So 3 different networks. this is for serial 0/0. This is for 0/1. This is for 0/2. This is my R1 router. R1 is connected to R2 router. What R1 router will do? If I configure like a OSPF protocol or EHRP protocol, so what R1 is doing is, hello R2 router, I have a 3 different networks, take you. It's going to update to the neighbor router, right? As a 3 networks. This of course is a 3 different networks, but up to which octet is the same? Up to which octet is the same? First octet or second octet or third octet? Up to how many octets the same information? Second octet. So by seeing the looking appearance, we can say first octet and second octet is the same information. 17.1, 17.1. But the thing is, even the third octet is also same. You know how? So to understand that, you try to write the first IP address in a binary language. Like how you can write as a first IP address in the binary? Yes, come on guys, tell me. First octet is same, right? First octet, second octet, leave it. So just write as a third octet only. First octet is 17.1 dot. Now third octet, tell me in the binary language. 1 means what guys? 0, 0, 3, 4, 5, 6, 7, 8 is a 1. Okay, good. Now, second IP address 17.1.2.1 in binary. 17.1 dot is the same. Like 2, you can write this in a binary language. How you can write it? 0.0.034567 and 8. 1 0. Very good. Now third one guys, the last place. 17.1.3. How we can write as 3 in the binary? 1, 2, 3, 4, 5, 6, 7, 8. So now you tell me guys, now how many, which octet is the same information? Up to which octet is the same information? So first octet is okay, 17.1 is okay, but still, so 6 bits are also at what same information, right? This is only last 2 octets, last 2 bits only, right? Last 2 bits. So remaining the same information, remaining 6 bits also same information. But this IP address, if we configure to in R1, if R1 is country neighbors, what R1 is doing is, we'll send the R2 router, hello R2 router, have a 3 different networks. 1, 2, 3 different networks means we'll send as a 3 updates. Yeah, repeat it, no problem. I'll repeat it. The IP address I'm using in my organization, my customized IP addresses. But by seeing the looking, we are thinking is what all are the same or different network. Okay, if it's a different network, up to which octet is the same? First 2 octets, 17.1.1. The similar, right? Okay, I'm writing as a 17.1 for second also 17.1, 17.1. Same. But what about third one? 1, 2, 3 means it's a different, right? Actually, it's a different, but thing is, if we convert into binary, okay, that is a binary. 1, 2, 3, 4, 5, 6, 7, 8. For second IP address, 1, 0. For third IP address, 1, 1. How 1, 1? First bit is 1, second bit is 2. 2 plus 1 is what? 3. Here, how 1, 0? Second bit is 2. Here, value is what? 2. How it is 1? Last is 1. We required 1. Okay, Pradeep? Right. Now 17.1 is okay, same information. Like even the third octet is also same information, right? So third octet also which bits are the same? First 6 bits are same. In first seconds, first 6 bits are same. Second third are 6 bits. Like up to 6 bits are what? Same information. But what my router 1 is doing is going to update to router 2. Hello router 2, I have a 3 different networks. We send a 3 updates. That is my first network, second network, third of course is a 3 different networks. But we are separating it. So what R2 will do? Okay, give me information. It's going to store 1, 2, 3 updates. Have there one more information is there like 17.1.4.1/24, 17.1.5.1/24 have a number of is there. Then what R1 will do? For example, have a 10 different networks. What R1 will do? Hello R2 have a 10 different networks. Okay, give me R2 is doing is what? It's going to store as a 10 different networks in the routing table. Like not only R1, R3 is also sending information, R4 is also sending information, R5 also sending the information. So now you can understand what about R2 routing table size. Too big. Routing table is going to increase. We have the number of updates, right? It's forming the number of updates. So to overcome this type of issues, what we are doing is we have one mechanism is summary. So just summary I will tell the R2 router. If is a example, this is my book. Any CCNA, whatever, like if it's a one book. The first or second page, what information you can get, guys? The first and second page, what information you can get? Index. Okay. Like index and summary, right? Like the whole information about the book, you can get the summary, brief information, the one page, in one line, in some only one page, you can get the whole information, right? So by seeing the summary, now we can have a very good idea about what is inside the book. The story, whatever the contents is a overall, we can get one idea. So to get the each and every information clearly, then you can have to open the book and you can go for each and every line, right? But I require the overview. I will require only the like brief information. So what I'm telling to here also have a 3 different networks. Is all the networks is being summarized, summarized. So I can send the information to R2 router. I have summary information only, that is 17.0.0.0 information. I'll send to R2 router. I'm not sending a 17.112.1121.31 like not like that. Just I'm sending the summary information to R2 router. Now R2 router is going to show the information in as a one update. If R2 require the detailed information, then if we open the packet, they can get the information detail. Initially, R2 itself is sending all the information to here, is sending the more and more updates, right? So we need to summarize our networks and we need to update to your neighbors. If you don't summarize your networks, what your router will do? Will update your router, a neighbor router. Neighbor router has to store the information, and your router, a neighbor router will consider have a number of updates. Bandwidth is base. Routing table is very too big. Router performance is going to down. So it's all the parameters we need to do. We need to see in the look over about real-time environments. Okay, here have a 1, 2, 3, LAN interface 4, one more interface 5. This is 6. Have a 6 different networks. 6 different networks in R1 router. So before sending update to R2 router, what I'm doing is I'll just send as a 17.0.0.0. Will send to router 2. Just summary information. Let me configure here. The practical. one router. We configure some loopbacks. Interface loopback 1. IP address 17.1.1.1 slash 24 means subnet mask is what? 255.255.255.0. Back to 17.1.2.1 loopback 3 17.1.3.1. To IP interface brief, we have the 17.1.1, 17.1.2.1, 17.1.3.1. Right? Now let me configure router EIGRP AS number 100. Network space 192.168.2.0. Network 172.16.0.0. Neighbor is being found. Network 17.0.0. 17.1.1.0. 17.1.2.0. 17.1.3.0. Three network. Now neighbor router, in neighbor, which is your head office router, if you check the routing table information, show IP route. So see here, guys, can you able to see here? 17.0.0.0 slash 8, which is a parent network. 17.0.0. But actually, I have configured how many different networks here? I have advertised here 17.1.1.10, 2.0, 3.0. Three different networks I have advertised, right? But what R1 is doing is already compressed this one, already summarized. You know why? Because in EHRP protocol, we have automatic summarization has been enabled. Then it's sending. We'll do one thing. We'll remove the auto summarization and we'll router EHRP 100 auto summary. No auto summary. Already auto summary is enabled. Even you configure different networks, it's going to summarize and send into update packet to neighbor. If you disable that, no auto summary. To IP route. I can see here how many networks in the routing table. 17.1.10, 17.1.2.0, 17.1.3.0. Sending as a 3 updates. Clear information is sending. So now you think about number of routers, number of networks is going to increase your routing table size. So to reduce number of updates, to reduce the routing table size, we do what? Summarization. And if you enable auto summary, by default auto summary is enabled. Enable it, then what R1 will do? Will compress it. Will compress it. Will summarize it. I will send as only one network as a update. If you see now, we have only one network. You can copy this. Sumrization. Less number of updates, reducing the size of routing table. Yeah, it will work on all protocols. For EHRP, automatic summary has been enabled. When ASPF, we need to enable, you have the manual auto summary. Manual to do. So to disable auto summary, can use this. Router RIP, no other. Enable default, and disable and can see the updates. Okay. Now let me discuss all the routing part based on the IPv6 routing. Let me check these routers are supporting or not. We'll change the router model number to IPv6. Let me design one to new to 2901 or is 29 in a two round. Where is the cross cable? And use the devices. Activity. Router to switch. Router to router. We use which cable? Which port to which port you need to connect? Generally. Serial port, right? Like up to now, we have discussed about serial port, but even you can connect for the LAN port to LAN port also. Pass Ethernet to pass. A cross cable for LAN port to LAN port. If you use a serial port with 35 cable, pass Ethernet 0/1 is already connected to your LAN. R1 to R2. Let me pass over cable from R1 gigabit 0/1 to R2 gigabit 0/. Let me configure. Host name Java. Interface gigabit connect 0/0. IPv6 address. Example 2001 colon 1111 double colon 1/. Let me take the network diagram. R1, R2. So you tell me guys now how they are connected. R1 LAN port. Port number is 0/, gigabit 0/. Even for R2 also, 0/. R1, R2 connected to via gigabit ports. 0/1. Here also 0/1. Now, for R1 router, gigabit Ethernet have assigned IP address, IPv6 address, which is 2001 colon 1111 double colon 1. So, as per routing conditions, R1 LAN, R2 LAN should be in a same IPv6 network or different IPv6 network. As per conditions of what? Different network, LAN to LAN, right? So, here I'm using here 2001 colon 2222 double colon 1, first usable IP address. And as per routing conditions, point-to-point connectivity, R1 gigabit, R2 gigabit, both should be in same or different network. Both should be in what? Same network, right? So here IPv6 address, let me making use here 2001 colon, let's say example here, 55555 double colon 1. Here also 2001 colon 5555 double colon 2. This is the condition. Let me design this one. R1 gigabit, okay, R1 0/1 gigabit 0/1 IP v6 address 2001 colon 5555 double colon 1 plus 64. Let me save the configuration. Now R2 configuration. R2 0/0 2222 gigabit 0/1 5555 2. Host name R2. Interface gigabit Ethernet 0/0 IPv6 address 2001 colon 2222 double colon 1 slash 64. shut down and exit. Interface gigabit Ethernet 0/1 IPv6 address 2001 colon 5555 2/64. Now configuration is okay. All interfaces are being okay. But LAN to LAN communication. How to enable LAN to LAN communication between these routers? Now LAN to LAN communication to enable between R1, R2. Now we have to implement what, guys? Routing. So already we have discussed about routing with the IPv4 network, right? Now let me say all routing between IPv6 network. Like here, routing table entries and routing mechanism update, everything concept is same. Only the commands I'm saying, I'm telling you actually. Configuration. IPv6 routing. So generally we use command to enable routing is a IPv4 routing, IP routing, right? How it is the command is not working in R1 router. IP routing. So IP routing command for to enable routing table for IPv4. Now if we check show IP route, just I executed no IP routing command, right? Use the show IP route. There is no routing entries. Why? Even I'm using here show IP interface brief. Gigabit 0/0. We assign IP is not showing. Why? Why? Because show IP route and show IP interface brief command, these commands for IPv4 network. But we just assign only IPv6, right? Then we can check IPv6 address, your brief information. Show IPv6 interface. Nothing get IPv6 information. In the routing table also show IPv6 route. I can get routing table information. What are the configuration of static routing? IP routes, destination network ID, destination subnet. But for IPv6, same command, but just use IPv6 route, destination network ID 2001 colon 2222 double colon 0 slash 64. Exit point gigabit 0/1. One command. The same configuration in a R2 also. IPv6 route 2001 colon 1111 network ID /64. X interface type is a gigabit 0/1. Now if we check routing table in R1 router, R2 router, yes, static is being updated. What was the command, guys, to verify the IPv6 routing table? We know about IPv4 routing table, show IP route. But what about IPv6 routing table? Show IPv6 route. You can ping. You can use a ping command towards your network. It's 2222 double colon 1. You get the reply. When you are in device to in device. Enable routing table in IPv6. IPv6 unicast routing. Assign end user IP addresses as IPv6 address. Desktop, IP configuration, v6 address, 001 colon, 1111 colon 10. What will the gateway address? 2001 colon, 1111 colon 1. Even for R2, desktop, IP configuration, 2001 colon, 2222 colon 10. Gateway, gateway as now if you check communication from your PC itself, the ping command 001 colon 1111 colon 10. Now check the gateway address up to pinging. Traffic is reaching up to your gateway. Take the ping communication here 2001 colon 5555 colon 2 getting reply. Like this. Even for RIP also. Remember RIP multicast address? Multicast IPv4 address is what? 224.009 is a multicast. 224 is a class D. Same for class IPv6 also FF02 is a multicast address. Double colon 9 for RIP. FF02 double colon 5 for what? OSP is a command. Configure RIP with IPv6. for OSPF. Thing is, router ID it should be with IPv4 network. IPv4 network. Router ID only IPv4. Can't use router ID is IPv6. It should be IPv4. Yeah, unicast routing should be enabled in all routers in R1, R2, also unicast routing. This command is what IPv6 unicast routing. Enable routing table in IPv6 network. For IPv4 network, IP space routing. IPv6 unicast routing. No, no IP routing. Routing is disabled. No IPv6 unicast routing. IPv6 routing is disabled. So this command you have to execute in all routers. Yeah, you know.
Zoom and GoToMeeting. These are the only three people. Okay, where majorly
In the routing, we have done about IPv4 and IPv6 both, right? So you can practice on it. If you are facing any doubts, let me know it. I can help you out through this thing. So finally, after implementing of routing protocols, implementing of routing protocols is very simple, right? Just configure of RIP and OSPF those things. The major part is after implementing of routing protocol, what are the drawbacks of the routing protocol, how to prevention it. The behavior of routing protocol is understanding is very important. The thing is, if we configure RIP or OSPF any protocol, what the protocol is doing is the protocol is going to do the utilize some bandwidth. Compared to RIP, OSPF it doesn't use the much bandwidth compared to RIP, right? Why? Because it has a incremental update. But still, RI OSPF also for every 10 seconds by sending updates by sending hello packets, utilizing the bandwidth. Even that we can't stop hello packets for all interfaces. If you stop the interface hello packet for all interfaces, complete your communication is being stopped. Then what we need to do? We have only one option is where your traffic is been wasting. on your switch. So to stop the hello packets on switch, we used to configure what? Passive interface. Is the one point. The one more point is in router, if we have the number of networks in a number of subnetworks, is going to advertise as a 1, 2, 3, 4, 5 different subnets, 5 different subnets. So means it's sending as a 5 updates. Is all the information is going to store in the routing table. Your routing table is also way too big. Then what we need to do here? Summarize. So summarize all the information. Just give the information to only summary information. That's it. So this type of points we need to consider. So one more point is if we run multiple routing protocols in one router, RIP, OSPF, EAGRP, is all the protocols if you configure in one router. So the router, how you can decide it, which protocol is how to work, is based on what? ADU, administrative distance, ADU value. Like have a RIP administrative distance is 120. OSPF administrative distance is 110. Right? For EIGRP, AD value is what? 9. Lesser AD value, higher the priority. So which protocol has a lesser administrative distance? That protocol has what? Higher the priority. So these are all the parameters in routing. Any doubts clearly? All of you? Any doubts regarding to the today's topic? So tomorrow we are going to discuss about troubleshooting, network troubleshooting. We have implemented routing, we have implemented switching, and implemented security part. And is all the parameters have been implemented. Now we require knowledge on what? Troubleshooting. It's very important session. And I have prepared some interview point of questions. Tomorrow we'll discuss all the questions. And if you are okay, and the day after tomorrow, I'll plan to willing. I can arrange one cyber security. We finalize in the tomorrow session for that. Okay, guys. Any more doubts? Deepak. Deepak. Yeah, Rakesh will conduct the cyber security, but we have a another staff is there. One of my senior faculty is going to do the cyber security. I am the tracking assistant. Yeah, Deepak, any doubts? Mustafa, Shiva. Yeah, Mustafa, like after CCNA, what I recommended means it depends upon not only after CCNA go for CCNP or cybersec, not like that. So a lot of parameters will come in the picture, like based upon your qualifications, based upon your where you're staying and which country you're staying, and what do you have any previous experience. Like a lot of parameter will come in the picture. So that person to person will be difference. So first I'll make arrange one cybersecurity demo session, and my senior faculty will give a guidance you like what are the after CCNA, what are the ways are there, then you can choose one of the way. Okay, guys. So that is what Mustafa I'm telling is after CCNA, what to learn about these things, and we have the proper guidance is there. One of my senior faculty will come to contact you, and they will make one demo session. So there you can get the clear information on that session. Sunish, Ram, Rakesh, Adi. Okay, right. Once again, thanks to all of you. I'm going to end the meeting now. Thank you, all of you.